off we go. So your title for this one, we're going to do limits analytically. That's your title. So we did limits from graphs. So we did limits graphically, which is where you kind of just look at it and go, oh, there's the answer. You just sort of point to it. Last time we did the limits to infinity and the limits of the piecewise functions. You just kind of pick which piece of the function you're going to plug into. For infinity, it's who's in charge here. Analytically means you don't have a graph or anything else to work with. You kind of just have to work it out by hand. And there's several different methods of approach. So I'm going to go through them one by one. So your first method of approach is plug in the value. Sometimes that just works. If it works, great. And you always kind of want to start with that. Like start by just trying it, because if it works, then it's really simple. All right, so number one, you're going to practice writing your notation here. Limit as x goes to 5 of x minus 1 over x squared plus 2. Before you do anything else, try and plug it in. If it works, you just get an answer and you're done. So always do that first. So if you plug in 5, what are you going to get? Good, over 27. 4/27 is your answer. Awesome. So sometimes it just works. Let's try that again. Limit x goes to 1, ln of x plus 5. I separated that a good deal so you could tell that it's just ln of x and then plus a 5. The plus 5 is not inside of it. So I want to see who remembers this. If you just go to plug in the number, you're just going to plug in 1. Does anyone remember what ln of 1 is? What's the other common number that we use a whole lot? Like if you had to give it a guess. E was a good guess, but it is 0. ln of e equals 1 is how that works. ln and e cancel out, you get 1. But ln of 1 is 0, and then 0 plus 5 is 5. That is one that you need to know, though, so let's try it again. ln of 1, 0. Very good. All right, so that's the first method. I'm not going to go over any more of those. Plug in the number. You just always want to try that first. Now, if you plug in the number and you get a value over 0, so like 3 over 0 or negative 12 over 0, that means that there is an asymptote. And so if you have a vertical asymptote, it has to be one-sided. If it's from both sides, remember how they won't connect? Then it has to be DNE. So this must be one-sided in order to get an answer. And your answer is going to be that the graph either goes up or down. If you have a vertical asymptote, that's how it's going to be. It's going to have to go up or it's going to go down. So it's either positive infinity or negative infinity. And you just test a number to see if it comes out positive or negative. So let's try a few of these. I'm going to do limit x goes to 2 from the left over x plus 7 over x minus 2. Now I know it's 2 from the left, but you're going to just try and plug in 2. That's your first go-to, is plug in the value, plug in the number and just see what happens. Okay. So if you plug in 2, what do you get? 9 over 0. And that's where you want to go, oh, there's an asymptote. So the next question is it one-sided? Yes, it's only from the left. So here's what we're going to do. We're going to pick a number to the left of 2, plug it in, and see if it's positive or negative. That's all you're going to do is test if it goes up or down. So can you give me a number to the left of 2? 1. If you plug 1 into this, what do you get? 8 over negative 1, which is negative. So your answer is negative infinity. You're just testing if it goes up or down, is all that is. Let's try it again. So you want to just plug in the value. Your first thought is always plug in the value. So if you plug in 10, what are you going to get? 20 over 0. You then want to go, oh, that's a number over 0. That means asymptote. So your next question is it one-sided? No, so it has to be does not exist. You can only get an answer if it's one-sided, because again, with an asymptote, if it comes from both sides, they're never going to be able to touch. They won't meet up. So if it's not one-sided, you can't get an answer. And we'll try one more of these. I know it's 7 from the left, but you want to just plug in 7. Plug in the number, see what happens, all right? So if you plug in 7, you're going to get -3 over 0. And you're going to go, oh, that means asymptote. Is it one-sided? Yes. Okay, so you're going to pick a number to the left of 7. 6. Okay. And I always get somebody that's like, I'm like, pick a number to the left of 7. And they're like, -1,000. For a limit, it has to be super, super close to what you're talking about. Remember how we zoomed in on the point? You have to pick something close. I get the, don't go too far away. So let's plug in 6 to this and just see what we get. If you plug in 6, you're going to get -4 over -1, which is positive. So your answer is positive infinity. You're just testing if it comes out positive or negative is all that is. All right, so value over 0 means that there's an asymptote. Next way that this can turn out is if you get 0 over 0. Now that is not an asymptote. What do you think that means? It means that there is a hole in the graph. And what you're going to do is try to get something to cancel out. You've done this before. The only difference is that it's going to say limit. That's all. You've done this before. We did a whole unit on it, finding the holes in the graphs. Back in unit 4. All right, you've done this. It's just going to say limit, and that always freaks everybody out. Oh, I forgot to number my problems. I'm sorry. Did you guys number them without me? I'm sorry. That was 4 and that was 5. So we'll call this 6. All right, limit x goes to -1. Now to bring up our first method of attack, the first thing you want to do is plug in -1. Because if you start doing a whole lot of work and then find out you could have just plugged in the number, you're going to be upset. Okay. So always plug it in first. And you don't have to write it down. You can just do it mentally. If you guys will talk to me, we can talk our way through this. -1 squared. Be 1. -1 times -5. It'd be 1 plus 5. So 6 minus 6 is 0. Down here, you would end up with 1 minus 1, which is 0. So 0 over 0. You do have to write limit when you go to your next step. If you don't put that, you have lost everything that makes it a calculus problem. That word limit is the only thing that makes it calculus. And then we're going to factor this. The idea is you want something to cancel out. So we're going to draw all of our parentheses here. We practiced doing one of these last time. Reviewing our algebra 2. So how is the numerator going to split up? Well, it will be 1 and 6. We would need +1 minus 6. This one trips people up. When it's x squared minus 25, people are like x plus 5, x minus 5. When it's x squared minus 49, people are like, oh, that's 7 and 7. When it's 1, it messes people up. But hey, guys, what's the square root of 1? 1. So it's going to be x plus 1, x minus 1. Oh my gosh, does something cancel? Awesome. Cancel those out. And then to get your answer, you're going to plug in -1 and just see what happens, all right? So if you plug in -1, what is that going to be? -7 over what? -2. And then negatives cancel, so 7/2. We'll do one more and I'll give you your break. That'll be a good halfway point. I'm going to change this one from x. I'm going to make it h. You do see that a lot in calculus. They'll make it h instead. So you always want to just try and plug in the number. Like just do that first. If you make h 0, let me cover it up. Do you see how you get 4x squared minus 4x squared? What's that going to be? 0, right? And then if h is 0, 0. So 0 over 0. We're going to have to do some algebra until we can get something to cancel out. So write your limit. If you don't write that, you've lost everything that makes it calculus. So make sure you write that. And we're going to have to multiply this out. So you can either write it off to the side, you can do it in your head, you can write it here a second time, but 4x plus h squared means that you need to write that twice. Or if you're capable of holding that in your head and doing it in your mind, that's fine, as long as you end up with the right answer at the end. All right, so let's multiply these together. 4x times 4x. Good, 16x squared. These are your algebra skills here. The outsides give you 4xh. The insides give you 4xh. So together, 8xh. And then h times h is h squared. Lots of algebra. Minus, and then if you square 4x, what are you going to get? Yeah, 16x squared. Good. And then this is over h. Do you guys remember? Because I showed you a problem like this earlier this year. That whole equation, and then the whole thing was over h, and then a bunch of it canceled out. That's this. This is a very important calculus formula. That's why I'm showing you. Right? So what cancels out? Because you should get something that cancels. Right? Does that ring any bells? Do you guys remember doing that? It was like yay long, and then everything canceled out. All right, and then what did we do next? Do you remember? You take out an h. So limit h goes to 0. You're going to factor out an h. It's GCF. What's left when you take out an h? Yeah, 8x plus h. These h's cancel. And when I showed you to this earlier this year, you just left that as your answer. 8x plus h was your answer. Well, now you have one extra step, which is plug in 0 for h. So what's your final answer to the whole thing? 8x. Do you have an older sibling that's taking calculus or a friend that's taking calculus and they mention derivatives all the time? You just did one. Congratulations. All right, so I'm gonna have to flip over because I ran out of space here. So this will be number 8. So we're gonna do one that has a square root in it. So again, your first go-to is always plug in the number. Again, if you do a lot of work and find out that you could have just plugged in the number, you're going to be upset. So do that first. So here we go. 4 plus 5, 9. Square root of 9, 3 minus 3 is 0. And then down here, 4 minus 4 is 0. So 0 over 0 means there's a hole. You have to somehow, some way, get something to cancel. Whenever there is a square root, you multiply by the conjugate. That's what gets things to cancel, is a conjugate. So instead of square root of blah, blah, blah minus 3, it's going to be square root of blah, blah, blah plus 3. Good. And you're going to multiply that to the numerator and the denominator. Now, this feels like a lot of writing up front, but in the next step, it's all going to like disintegrate. Like the problem's going to just fall apart because it's all going to cancel. So like you have to write that up front, but when you go to the next step, it's not going to be bad, I promise. It's sort of all going to go away. So you still want to write your limit. Again, if you get rid of that, you've gotten rid of the calculus. Also, you'll probably forget to plug in 4 at the end if you don't write that. Your last step is plug in the number. So let's multiply these and see what we get. square root of x plus 5 times square root of x plus 5 would just be x plus 5. And that's like the point, is that the roots cancel out. Now, when you do the outsides and the insides, you're going to get plus 3 square root of stuff. And then the insides are minus 3 square root of stuff. So those, I wouldn't even write them. They go away. And then your last, negative 3 times positive 3 is negative 9. So see how a lot of it went away? That was the whole point. Now, in the denominator, you want to do nothing. What are we going to do? Nothing. All right. You're going to keep all this exactly as it is. If you want to put parentheses around that x plus 4, you can, but basically just recopy it. Just don't do anything. You just rewrite what's there, and that's it. Now, then you stop and take a step back and go, okay, what do I have here? X plus 5 minus 9. What's that going to equal? That's x minus 4. So what do you notice? If that's x minus 4, they're going to cancel out. Thank you. And then you can get your answer. Now, the entire numerator's gone, but there's still something there. What is there? No, good. 1. And then you plug 4 in to what's left. So 4 plus 5 is 9. Square root of 9, 3 plus 3 is 6. So 1/6 is your answer. So recap, if there's a square root, you multiply by the conjugate, and then everything's going to kind of fall apart. So let me recap all of our methods so far. What was first? Plug it in. Just try that first. Sometimes it works. If you get a number over 0, it's an asymptote. Check if it's sided. You either get positive or negative infinity, or if it's not one-sided, then you're going to get does not exist. If you get 0 over 0, it's a whole. You have to do some algebra. Those are the annoying ones. You have to do work, all right? So you get something to cancel out. If none of that works, your Hail Mary, go for broke, is draw a graph. If nothing else works and you're just not sure, draw a picture, because the visual will help. We'll do a couple of these. Like if you get stuck and you're like, I have absolutely no idea what to do, you're gonna draw a picture. I'm also gonna review what these graphs look like. We did them, but it was like back in unit 2. So, you know, September, October-ish. That's not an absolute value. Does anyone remember what that is called or what it looks like? I'll take anything that you remember about it. I know someone does. You guys are just super quiet. Does anyone remember what it looks like? It's the staircase one. And it's moved what direction? Up 1. So you're going to go up 1, put a point. That's where your first step is. Does anyone remember what it's called? It's 2 words. G. Good, greatest integer. Did you do those in algebra 2 as well? Or not really? Okay. We did them. It was just a while ago. All right, so put a few more steps in there. I didn't stretch or shrink it on you. We did those earlier in the year, but you know, for this, I just figured we'd just do the basic graph. I just moved it up 1. So go up 1, that's where your first step is, and then just draw a couple of steps in. It's your staircase one. Greatest integer. Good, so you remember what it was called and what it looked like and everything. So we want to approach 2 from which side? Now you're gonna have to watch me point to this because I don't have a better reason than, hey, look, here's 2. Look it. If you go from the left, you're going this way. I realize there's a hole there, but it doesn't matter. What value are you at? 2. So this answer is 2. But I'm going to change it. I'm not going to make you draw another one. We'll just go from the other side. So it's the exact same problem. I just put a plus in there. So again, watch me point to it. Here's 2. If you go from the right, what value are you at? Is 3. Good. So is the function continuous there? No. Removable or non-removable? Non-removable, see, our vocabulary activity helped us. And what do we call that type of discontinuity? A jump. Good, perfect. I knew one more. You guys remembered all of your vocabulary. Very nice job. So do you remember e to the x? Remember me going like this? Exponential is a swoop. ln is a sideways swoop. What direction did this move? Up, down, left, or right? Left 2. You're going to go left 2, dot in the asymptote, and it's going to look something like that. Sideways swoop. And then you kind of just use the picture to answer the question. We want to approach -2 from the right. It's really good it's from the right and not from the left. Why? Like there's no graph over there. So if you approach -2 from the right, where is it headed? Yeah, -infinity.